Okay, we're all set now? Fantastic. Well, thanks for having me here, and appreciate doing some technical gymnastics to get me down there when I couldn't quite make the drive. So today, I'm going to talk a little bit about internet exchange points, what they are, why you should care. I'm sure there are some folks in the room who this will all be old hat and very well-known information, but hopefully there's also quite a few folks there who will learn something from this presentation. So hopefully this is helpful. Just to kind of give you a rundown of what I plan on going through over the next 20 minutes or so. First, just a quick introduction, and then kind of zooming out to look at the internet itself and how the internet works. Because a lot of people, I think, just treat it like electricity. They turn the light on and it works. But digging behind the walls is kind of interesting sometimes. And then that will also shine a light on what an internet exchange point is and why internet exchanges are important. And then finally, a note about bringing an internet exchange down there to Southwest Colorado. So first, I'm going to start with the kind of who am I, which otherwise known as the who let this guy in question. And so, I won't drone on too much here. I have been doing this for quite a while, about 20 years in networking. I currently work on a few different projects, including IX Denver, which is a nonprofit internet exchange in the Denver metro area, and expanding throughout Denver. And I've done a few other things along the last couple decades of working in network engineering. So jumping into the important stuff here, the first thing I want to talk about is what is the internet really? And so one very technical answer is that it's a protocol suite of TCP and IP. I think a more accurate answer is it's a network of networks. And then, of course, for most of us, day to day, it's how we communicate, how we learn, how we heal, how we do business. It's how we access critical services in our communities and abroad. And it's also how we build the future. So, digging into the first couple bits to kind of get a better understanding of how the internet works versus just what it does for us in our lives. TCP IP, this is the slide I'm not actually going to go into. So hopefully there's some sighs of relief from some folks. But there is kind of this protocol stack behind the internet, which is how it works. But really what I want to talk about is some other more common misnomers. So one thing is the web is different than the internet. So the web is the web, so to speak, of websites that exist on top of the internet. So it's a different set of protocols. This is one map of the web. And if we zoom in here, we can see that some of the big dots are some of the big websites, content properties out there on the internet. So the difference here is that the web kind of lives on top of the internet. And one of the best things about the internet is that it can support many different protocols and different kinds of applications and content on top of it. So while we used to do just websites, there's now streaming data, Internet of Things. There's a lot of other types of data and content that goes across the internet other than just the web. This slide's also from 2010. So some of the sizes of the websites on here would have changed by now. So if the internet is not the web, then what is the internet? One way to think about this is the physical connectivity. And on the largest scale, that's between continents, right? So this is a current look at undersea cables that connect the world together, or at least connect the continents together. So this is starting to get closer to a view, I think, that's useful of what the internet really is. This is a physical layer that kind of underpins the internet itself. If we zoom in a little bit on this into the United States, some folks did a research study of long-haul fiber in the United States back in 2015, and this is the map they came up with. You can see that although this map isn't laid over a map of the United States, you can tell that the fiber pretty much runs throughout the entire United States. I will point out one thing. I don't know if you can see my mouse, but towards the middle there, you can kind of see a string of red dots that is, up I-25 through Denver. And then to the left and down a little bit, you'll see one of the biggest open areas in that long haul fiber map. And that's exactly where the Four Corners area is. So, definitely some work to be done there. And I'm glad that I can be part of this meeting where you all are talking about that. So this is a map of fiber. And again, if we're trying to understand what the internet is, I think fiber is a part of it. But again, just like the web may be too high up the stack, the fiber may be a little bit too low down the stack. When we talk about the internet, I think what we're really talking about, again, is kind of back to that TCP/IP protocol suite. It's the network of networks that are transmitting data around the world. So this is a map from 2003 that shows those connections between these networks. And it's also better seen, I think, through this video, which we won't watch the whole thing, but this shows the evolution of the internet from 1997 through to 2021. And what you can see here is each of these lines represents a network. The blue ones are the United States, the green is Europe, the red is Asia, I think the yellow is Africa, and I think there's a pink or purple that's Latin America. And you'll see as the internet grows and the years kind of roll on here, this white part in the middle starts to form up as well. And that's what folks call the internet backbone. And what defines the backbone is simply how well connected it is. So the networks that are connected to the most other networks kind of gravitate to the center of this map as things move on. And you can kind of see here down at the bottom, the biggest networks at the time, the most interconnected networks at the time are listed and kind of scroll over in that lower left-hand corner. And you can also see where they're at on the right-hand bottom corner. Obviously, North America and Sprint dominated through the early 2000s. And then that'll change if we watch this whole video through. But the most important thing, I think, is really the idea that the internet is this series of networks that are connected together. And what the internet really is internetworking, right? It's the idea of this network of networks, and that the way that a person who maybe lives over here, let's say maybe this is South Korea, can talk to a person who maybe is over here in South Dakota is by connecting these networks together. So you connect to your local network, that passes it off to maybe a local or regional network, that passes it off to maybe a national network, which then goes under one of those undersea cables through a provider like that, and on through this series of networks. The routing protocol of the internet actually works exactly like that. There is a autonomous system number assigned to every network, and the path is just a list of those numbers. So it's just a list of networks that information must traverse to get from wherever it's coming from to wherever it's going. So that's kind of the internet. And then when we understand that, we can start to talk a little bit more about internet exchange points. At the base level, an internet exchange point is a switch. Typically, there's an organization that operates that switch. But most importantly, it's a physical point of interconnection. So as you saw on that map, how things were moving around and those networks were kind of connecting to each other and disconnecting from each other, and some were becoming more and more connected and some maybe less connected. Where that's happening in large part, especially today, is at internet exchange points. I kind of think of them as the knots. They're tying these networks together into the internet. They're what actually create the internet by allowing these networks to connect and create a overall network of networks. There's some logos on here of some of the bigger and more prominent internet exchanges around the world and in the United States. AM6 is in the Netherlands. DKIX is in Germany. Lynx is in London. And then in the US, because we're quite a bit bigger geographically and population-wise, we've got one in San Francisco, one in Seattle. Obviously, I'm here today from IX Denver. And again, all of these are all of these things, right? They're a switching fabric where networks can actually physically connect to each other and then logically peer their routes over. And then there's obviously an organization behind these that operate them. Another way to look at this is from someone other than myself. So I'll just read these quotes here, starting with the bottom one. An IX is the physical connection and infrastructure where networks exchange internet traffic. So hopefully after kind of seeing how the internet's built and talking a little bit about this, that makes somewhat sense. Another way to look at this is while the network providers may be the foundation of the internet, internet exchange points can be considered the glue that holds the internet together. So another analogy, like I said, I like knot. This person looks at glue that ties everything together. It might be helpful to look at this kind of a physical diagram of what actually happens here. And again, at the simplest level, an internet exchange point really is just a switch. And so you've got ISP A on the upper left there, ISP B, content provider B, content provider A, and they're all connected to this switch. And so the content from content provider B can now be consumed by the customers. A lot of times in the industry, they're called eyeballs because they're looking at content. from ISP A or ISP B. And what's nice here is that there's this kind of direct path between the content and the users. And so a lot of things happen there, which is, local traffic stays local, which minimizes latency, jitter, and packet loss. So it makes the quality of the experience better. Also, because you're connecting locally, there's less of those transport hops, less routers, less networks you have to go through, which makes the whole thing more reliable. It also maximizes bandwidth because internet exchange points operate at LAN connectivity. It's not like old T1 or DSL or anything you might be using to kind of connect from far away. When you're connected to an internet exchange point, you're connected right at a port speed of 1 gig, 10 gig, 100 gig, and in the future beyond. Also, one of the things this model does is to reduce costs for members because you don't have to pay transit for traffic to go between member networks, right? And so, ISP A and ISP B, they may, and without that exchange there, they may have to pay someone to get their traffic to or from the content provider. And when they're connected to the internet exchange, they do pay a membership fee to be a part of the exchange, but they don't have to pay per bit or per mile or any of the charges that happen when you're doing long haul transport or internet service on the transit side. Again, another thing this does is adds regional fault tolerance. When you add these exchanges, the more points of connectivity there are between networks, the more interconnected these networks are, the more failures can happen without actually breaking anything. And so even when specific links may be degraded or even down or cut, there's a lot of those fiber-seeking backhauls out there. Traffic can still flow locally without any interruption if everyone is connected to the local exchange. Another advantage of internet exchange points is they often bring major content sources directly to the exchange. So folks like Google, Cloudflare, Facebook or Meta or whatever we want to call them. Cloudflare is a content provider that serves a lot of the content you normally look at. Obviously, we know who Google is, Netflix. There's a lot of other folks out there that have all these content sources, and they connect directly to these exchanges, bringing that content closer with all these other benefits, right? So lower latency, lower jitter, lower packet loss, greater reliability, greater fault tolerance, less cost, all those things. And then, internet exchanges are not really competitive to each other. They provide additional traffic interconnect locations for additional redundancy against other peering fabrics. So exchange points kind of support each other just as much as they support other ISPs or the content providers themselves. So I want to bring this into kind of, more of, again, an illustrative example here of how the internet works and then how an internet exchange point can affect that, right? So this is a really simple example. You can see I've kind of got a yellow user, a purple user, and a red user down across the bottom. They each have their own local ISP. On the right-hand side, there's a regional network service provider, and then you've got these national ISPs kind of up at the top there. And in this example, if the purple guy wants to talk to the red guy, maybe the red person has a server with some information on it that the purple person is doing some research and needs to understand, or maybe they're playing a video game together, for whatever reason they're connecting. They're going to pass their traffic off to their local ISP, who's going to then forward it through the regional network service provider to the other local ISP, and this goes kind of both ways. And so while purple guy here only has a commercial relationship with his local ISP and the red person over here only has a commercial relationship with the ISPC, their traffic's actually being passed by another company altogether. One that probably both these local ISPs are paying for transit services or transport services. And then if we look at this, from the other side, it's way worse for the yellow guy here if he wants to communicate with the purple gal. And that needs to go through this national ISP, another national ISP, down to the regional ISP, and through the local ISP. So, potentially there's actually 5 different networks that need to pass this traffic in order to get from one to the other, which definitely can add some latency. These two folks may be on the same block, but at least in the same town. And because they chose different ISPs that just have this type of connectivity, that traffic has to round about through who knows where, probably Denver, maybe even further away. And then, worse than just the latency, you can have these failures that happen upstream with or between ISPs that you don't even know about that can cause a failure of your connection. So you become reliant on these third parties. And this is just a normal way the internet works. It's all best effort traffic. But of course, because you can't see where these connections are and you don't even know about them, and you're not even paying or have any kind of contract or relationship with, this national ISPY up here, this could happen anywhere. There's multiple unknown failure conditions, and it doesn't have to be a complete failure either. This could just be a congested port, right? Or a router that's running really hot and has limited memory. And so packets might be being discarded at that level. And that affects your local experience because you're reliant on these, faraway third parties. Now, what happens if we add a local internet exchange? Let's say that all three of these local ISPs are great internet citizens, and they sign up and become members of the local internet exchange. And so they're all connected to, we're calling it Southwest Colorado Internet Exchange here. And they all connect here. And now I think you can probably imagine exactly what's going to happen. That local traffic stays local. So now, instead of having to rely on this regional network service provider or any of these national ISPs, the local ISPs are exchanging traffic directly between them. And so, the scenario now, instead of like the worst case that we saw before of 5 different networks having to pass this traffic, it's only ever 2, no matter who needs to talk to who, whether it's, red to yellow, yellow to purple, whoever is, consuming content and providing content, it's just 2 hops. It's just through your local network, across the exchange, and then through the local network of the local ISP for the other user. So you can see, right, this is going to eliminate a lot of those unknown failures upstream. It's going to increase the resiliency of the whole network because, of course, if the internet exchange were to fail, you can still go the old path. That normal path is still there. You have higher capacity and a lot of other benefits of just having traffic stay local. Another thing that happens is if this exchange is, well known and well run, they're going to bring all of these big content folks to connect as well, right? So Google, Facebook, Amazon, Netflix, Cloudflare, the list kind of can go on and on. Microsoft, other folks, and these big guys, essentially become locals. They're connected to this same local internet exchange, and they're only a hop away now from any of the users of these local ISPs. And so you've kind of really brought connectivity that normally only happens in big cities out to, wherever you may live, assuming your ISP is connected to a local internet exchange. And finally, this also works for local services, right? So, I know I took a look at the city of Cortez's website as an example, since we're having this meeting in Cortez, and there's definitely some things there. You may want to look things up or pay taxes or services you have available to you on the kind of local government website. If the local government also connects to the internet exchange, then all of this traffic that may come from the local citizens can go directly to that portal without having to be transported across, a regional or national ISP. It can save the city money and can increase reliability for those services across the serviced region. Finally, I just want to leave you with a note. Now, this quote is from 2000, but I think it's still very relevant. The ITU is the International Telecommunications Union. They're a part of the UN, and no matter how you feel about them, they have funded quite a bit of research into this space, and they advise a lot of national governments around the world on policy issues. And according to ITU surveys, interconnection-related issues are ranked by many countries as the single most important problem in the development of a competitive marketplace for telecommunications services. There's a link on this slide as well, which we can distribute later, that kind of goes into more detail of that report. But I think you can see how interconnection and internet exchange points that facilitate interconnection are vital to the conversation about increasing broadband penetration and the user experience of the internet in all parts of the world. So finally, closing out, I just wanted to mention that IX Denver is, so IX West is the nonprofit organization that owns IX Denver. IX Denver is the local interconnection fabric for our area. Our mission is to provide open, neutral, community-oriented, and membership-based interconnection exchange points. We are a co-op, so our members only pay as much as it costs us to keep the thing running. And our vision here is to constantly improve interconnectivity across the internet community. And you can see there's a traffic graph here for those of you who read these kind of things. We're peaking at decently above 100 gig every day now. We've got about 68 members. Most of the big companies I named, I think actually all the big companies I named in this presentation are already members. And we have already been in talks with the folks at 2210 Cortez to bring IX Denver's interconnection fabric down to that area. And so, we encourage everyone to eat local, drink local, shop local, but also peer local. Let's connect all of our local networks together and exchange traffic as locally as possible to save everyone money and increase reliability for the internet in our area.